Coordinate systems are essential in linear algebra because they allow us to describe points, lines, and shapes in space with simple sets of numbers. They are the foundation for understanding scalars, vectors, and matrices, which are fundamental concepts in linear algebra. We are constantly analyzing the world around us, processing the phenomena we encounter based on our understanding and the tools available to us as human beings. So, we are selecting a space in which these phenomena happen. Our surrounding space can be quite large and we are not limited to a specific boundary. The coordinate system represents the numerical shape of the surrounding space, providing us with the ability to measure and quantify these phenomena mathematically. With the use of fundamental concepts like the coordinate system, we can model the realities of our life in mathematical language and employ advanced equations, functions, and concepts to investigate them. As we navigate the mysterious of the cosmos, our understanding is limited by the boundaries of our chosen coordinate system. These systems can adapt to our needs and limitations. For example, consider the motion of a ball in space. We can measure its motion in one or two dimensions. By adding another axis, we can measure its motion in another dimension. And as needed, we can even include more dimensions. We should consider that as humans, our eyes perceive the world in three spatial dimensions. The most commonly used form of the coordinate system is called the Cartesian coordinate system, named after the French mathematician and philosopher René Descartes, who attempted to combine algebra and Euclidean geometry in his work. In the Cartesian coordinate system, for a one-dimensional space, axis is a straight line. For more than one dimension, the axes stand perpendicular to each other. Consider movement of the ball again in one-dimensional space. Its movement just analyzable in a straight line. In two-dimensional space, movements are in two different directions. And also, for three dimensions, we have three separate dimensions to measure. At the heart of it all lies the origin, the crossroads of the axis. The origin, which usually denoted by the letter O. It's the cornerstone for locating every other point in the system. The origin divides each of these axes into two halves, a positive and a negative. Points can be located with reference to the origin by giving their numerical coordinates. That's the position of their projections along each axis, either in the positive or negative direction. When we use the Cartesian coordinate system, we often deal with two-dimensional or three-dimensional spaces. In a two-dimensional space, the coordinate axes are labeled as x and y, and the set of ordered pairs x and y represents the points in the plane. Similarly, in a three-dimensional space, we have three coordinate axes labeled as x, y, and z, and the set of ordered triples x, y, and z represent points in 3D space. For example, the point 1, -2, and 3 represent a location where the x coordinate is 1, the y coordinate is -2, and the z coordinate is 3. The values of x, y, and z can be any real number. And that's why we use the symbol r to indicate the set of possible values for these coordinates. When our coordinate system has two axes, it means we are in a two-dimensional space denoted as R2. And if the coordinate system has three axes, we represent it as R3. But what numbers are considered as real numbers? Real numbers are a set of different type of numbers. Integers like -3, -2, 0, 1, and so on. Rational numbers, which be made by dividing an integer by another integer, like 3/2 or -1/3. Irrational numbers that cannot be written as a simple fraction of two integers, like the number pi. So far, we have learned about coordinate system in this episode. But another important preliminary part is to learn about the elements that make up linear algebra: scalars, vectors, and matrices.